Okay, the square diagonals conjecture. The diagonals of a square are going to be congruent. The diagonals of a square are going to be perpendicular. And the diagonals of a square are going to bisect each other. One of the tricks here is you can use your segment straight edge tool, and you can make segments on top of the existing segments. And what that allows you to do is you can then click on them and simply measure those lengths. Okay, and let's change this one to say point E. Okay, so the diagonals of a square are congruent, the diagonals of a square are perpendicular, and the diagonals of a square bisect each other. Conjecture number 50, the three midsegments conjecture. The three midsegments of a triangle divided into four congruent triangles. So what are we going to say here? We want to show that the length of a midsegment, and I guess I can start with this midsegment here, the length of a midsegment is equal to half the length of the base. So if this is two equal lengths here at the bottom, this is going to be one equal length here. And then same thing here, if these two segments are equal, then this one also has the same length. And if this is a length of 2, this would be a length of 1. And so you can see here within these four triangles inside that by side, 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 all four triangles would have to be congruent. And as you move it around, you can show that. Conjecture number 51. The triangle midsegment conjecture, it states a midsegment of a triangle is parallel to the third side and half the length of the third side. So what do we want to show here? We want to show that the midsegment is parallel to the third side. So I'm going to measure their slopes. If their slopes are equal, then the lines must be parallel. Okay. And I also want to show that it's half the length of the third side. So what I'm going to do is I'm going to measure both the midsegment and the third side. I'm going to measure those lengths. And I want to show that if I go to number and calculate, that if I take the length of the third side and divide it by 2, that will show the length of the midsegment. Okay, so the length of the third side divided by 2 is the length of the midsegment, and if you move that around, you can see that. Okay, our last conjecture for the chapter, the trapezoid midsegment conjecture. The midsegment of a trapezoid is parallel to the bases and is equal in length to the average of the length of the two bases. So first, let's come up with a midsegment. If you select the non-parallel sides, and you go up to construct, and we're going to choose midpoints, and I connect those two midpoints, that's the definition of a midsegment. I first want to show that the midsegment is parallel to the bases, so I'm going to measure those slopes, and if the slopes are equal, the lines must be parallel. Okay, and then I also want to show that the length of the third side, or excuse me, the length of the midsegment is equal to the average of the sum of the bases. So if I take the measure of all three lengths, the measure of all three distances, I want to prove, that did not give me what I wanted. Let's try that one more time. Okay, so I deselect everything. I highlight these three segments, and I'm going to go to measure lengths. There we go. So what I want to show by calculation is I want to show that the average of the length of the two bases, so from B to C, plus A to D, and if I take all of that, let's see if I can put some parentheses in here. So let's do open parentheses. Let's do the length of C to B plus the length of D to A, and I'm going to take all of that and divide it by 2. Okay, so that's how you find the average, and we say okay. And you can see that the average of the bases is equal to the length of the midsegment. And as this moves around, you can see that that property holds true.